Okay, we're talking about segment addition postulate, all right? And that basically what this is telling us is that if you had two segments that make up one big segment, you can add those two segments, FG plus GH, and set it equal to the whole segment, FH. So in this question here, you can see that you have FG, which is x plus 2, and I like to fill out the segments. It helps me organize what I'm doing. I'm sorry, that was, yeah, if FG is x plus 2, GH is 3, and they have FH is 2x plus 1. So I'm literally just taking these pieces, FG, I'm taking FG and I'm putting that in here, x plus 2, plus GH, 3, is equal to FH, 2x plus 1. And just like we talked about in the warm-up, combine like terms, x plus 5 is equal to 2x plus 1. Move letters to one side. Move numbers to the other. 4 is equal to x. And then usually they'll show you answer choice A will be 4. But we have to always be aware of and focus on what is the question asking. Well, actually, they're asking for FG. And if FG is x plus 2 in this case, well, then I could just take this value for x, plug it in, 4 plus 2, FG is equal to 6. Here's another that you guys have where they kind of fill it out for you. So they've done some of the work for us. So we're just going to take CD plus x plus 11 and set it equal to 18. We have our combined like terms. And in this case, again, we have x is equal to 1. But let's just say this was, let's make it 22. I'm going to change this. And you end up with 16x plus 2 is equal to 22. And the reason I'm going to change this is so we can look at something with a fraction in it, because it talks about proper fraction, mixed number, or integer. So when I get 16x, I get 16x equals 20 divided by 16. X is equal to, we'll reduce this by dividing by 4. So I divide by 4. A couple little fraction things we need to look at here. And we end up with 5 over 4. So x is equal to 5 over 4. So if I'm substituting in to DE, and DE is equal to x plus 11, and I'm going to sub in the 5 over 4 plus, yeah, make sure we have ourselves on mute here. We have a 5 over 4 plus 11, and what we need to do is talk about how we can change this 11 over 1 to have a like denominator. So what I'm going to do is I'm going to have 5 over 4, and the lowest common denominator is 4 here, and I have 11 over 1, and I'm trying to basically change the fraction to have a like denominator. So I'm doing times 4 on the top and bottom, 44 over 4, 5 over 4. So I end up with 5 over 4 plus 44 over 4. This number did not change. 44 over 4 is 11. So we just changed the pieces, the size of our pieces, so we can add and subtract them. And you end up with adding just tops, not bottoms, 49 over 4. And then you could say 4 goes into 49 12 times with 1 left over. How did I get this? Let's bring that over here. Well, basically, if 4 goes into 49, 4 goes into 4 once, 4 goes into 9 twice. So subtract 8, and you end up with that remainder of 1. And that's what you do. You put that remainder over the denominator. So this is a little fraction one. I see that we've had a little challenges with that, so I want to bring that up. This is a great one because here, this actually requires the most work because you have to actually create this geometric figure. You have to create this diagram. So segment PR has a point Q on it. And then I'll say, okay, well, my PQ is 17x plus 2. My QR is 7x. And I have a PR of 20x plus 17. As soon as you give yourself a visual of this, this is really going to help you properly set up your algebraic equation to solve for x. And we want to do 17x plus 2 plus 7x is equal to 20x plus 17. We want to combine like terms, 24x plus 2. We could see the numbers are getting maybe a little bit challenging to use here, but we stick to our Miltos motto, move letters to one side. I'm moving to the left because by subtracting 20x from both sides, I end up with a positive 4x. As opposed to moving to the right, I would end up with a negative 4x. Move letters to one side, move numbers to the other. I get 4x is equal to 15. But then you're like, oh no, 15, 4, they're not, what do I do? Well, just stick with it. Okay, 15 over 4. Stick with this fraction. We don't need to make this a mixed number yet. Stick with this. Let's see what we have to plug into first. QR. Ooh, this is a multiplication one. That's good. QR is 7 times 15 over 4, which is really 7 over 1. You're going to multiply with fractions. You're going to multiply across. So what I like to do is 7 times 10 and 7 times 5. So I have 70 and 35, which means 7 times 15 is 105. It's a little mental math trick there. A way for me to multiply without doing the 15 times 7, 5, carry the 3. This is actually the mental math way here. So I have 105 over 4. You could use a calculator, 105, and say to yourself, okay, 105 divided by 4, 105. Watch this trick here too. 105 divided by 4 is 26.25, right? Now I know 0.25 is 1/4, so I could call this 26 and 1/4. But if I'm using a calculator, I could just say, okay, well, if 4 times 26 is 104. 4 times 26 is 104. Well, then I'm just going to have 1 left over, and that's where I end up with the 26 and 1/4. So here's another one where you have some multiplication. This should help you guys with your segment addition postulate problems.